Hi everyone, it's Mrs. Bebo. In this video, we're going to take a look at solving equations with a variable on each side. These are my favorite types of equations because there's lots of options on how to go through and solve them. So let's go ahead and get started. Our learning target for this video, as well as the two following videos that go along with this, are how do I solve an equation with a variable on each side. So the thing about equations when the variable's on both sides is it opens us up to a world where there's more possibilities than just one solution. So the one solution is what we're used to when we solve equations, right? An equation has one solution if exactly one value of the variable makes the equation true. We've solved equations like this starting back in 6th grade, right? And this is going to still happen when we solve equations with variables on each side. It's just now we might not always have just one solution. We might have a situation like shown in the middle here where we have a no solution. So there's no value that actually makes this equation true. So for example, if we have something like this 2x plus 5 equals 2x plus 4, when I subtract the 2x, I'm left with a statement that says 5 equals 4, which as you all know, that's not true. And so we would write this as a no solution or an empty set or a null set. And then that's it. So sometimes we're going to have situations where there actually is no possible answer. There's just no solution. And then we have the identity. So an identity is an equation that is true for all values of its variables. So again, I have a situation where both sides are exactly the same. And this means no matter what I plug into this equation, there's always going to be a possible answer, right? So it's true for all values of x or infinitely many solutions. We'll take a look at a no solution and identity types of examples in a later video. For this one, we're going to look at ones that actually have one solution just like we're used to. But just know that when you have all of these mixed together, especially on your practice assignments, there's the possibility of having an identity, a no solution, or again, as we're used to, a one solution situation happening. Okay, so we're going to take a look at equations that have, again, variables on each side. I love these, like I said, because there's so many different ways that you could start these. So for this first one on the left here, it says solve 5 plus 7a equals 4a minus 13. And then it tells us, as a good reminder, we should check our solution. So when I take a look at this equation, 5 plus 7a equals 4a minus 13, your goal is to, again, isolate that variable. You could start off by subtracting 5, I could subtract the 7a, I could subtract the 4a, I could add the 13, right? Both sides of the equation, make sure you're doing the same thing, but you have 4 options of what you want to move or get rid of from one side or the other. It can get kind of overwhelming when you have so many choices, so I always tell my students, start with a variable term, so either the 7a here or the 4a, and I always suggest taking away or adding one to both sides that's going to leave you with hopefully a positive coefficient. So that way you don't have to worry so much about negatives and losing track of them. So in this case, I want to, and again, this is not the only option, but I'm going to subtract the 4a. And I'm actually, before I even start writing any of that down, I'm going to go ahead and draw a line through my equal sign just so I can make sure I'm keeping my work organized. And whatever I'm doing to one side of my equation, I'm going to make sure I'm doing to the other. So like I just said, we're going to go and subtract the 4a from both sides, because what happens now is once I subtract that 4a, I have this statement here, 5 plus, well, the 7a minus 4a would make 3a. Equals, and then this is going to be a negative 13 because we do have to make sure we carry that subtraction sign down and put it back in front of that 13. So again, subtracting the 4a, not the only option. I could have subtracted 7a, I could have subtracted 5, but again, choosing to do that left us with a positive coefficient, and then this right here, now it's just a two-step equation. This is something you've been practicing for quite some time now. So next, we're going to go through and take away this 5. So we'll take away 5 from both sides of our equation. And I'll have 3a equals a negative 18. And then our last step to solve this is to divide both sides by 3. And we end up with a equals negative 6. And when it says to check our solution, again, solving equations is awesome because you can really make sure that you've done it correctly every time by taking what you get for your answer and plugging it in back into the original equation to see if it's true. So if we just take a moment to do that, we're going to write 5 plus 7, and then parentheses negative 6, and we're saying, okay, does this equal the 4 times negative 6 minus 13? So we're going to have 5 plus negative 42 equals negative 24 minus 13. So 5 plus negative 42, that is going to put me at negative 37. And then on the right-hand side, I'm also going to get negative 37, which means that my equation checks out. All right, so let's take a look at another one. With this one, again, it says solve 5 minus 13c equals 4c plus 39. Check your solution. So just like the previous problem, we have a variable on each side here. And so just like I said before, you have choices. If you want to subtract the 5 to start, you can. If you want to add 13c to start, you can. You can subtract 4c and you can also subtract 39. You got 4 choices of what you can do with this. My advice would be to, again, start with one of the variable terms. So either this negative 13c or this minus 13c or that 4c. And to determine which one, I would get rid of the one that's going to make it so that you don't end up with a negative coefficient, right? So in this case, I'm going to add the 13c to both sides to start. So I'm going to write add 13c, add 13c. So again, on the left-hand side, just like the previous question, that's going to cancel out. So I'm left with just 5 equals. And then 4c plus 13c is going to be 17c. And then we have this plus 39. And now it's just a two-step equation. How do I get rid of that constant that's next to there? We're going to subtract it. So subtract 39 from both sides. This is going to put me at negative 34 equals 17c. And then our last step is to divide. So we're going to divide both sides by 17. And then we get an answer of negative 2. So negative 2 equals c. Just like the previous question, we're going to take a moment just to double check that this is actually correct. It's a really good practice to get into, especially on an assessment. Just take a moment and double check it that you've actually done all your steps correctly. So we're going to do 5 minus 13, and then in parentheses, negative 2. We're asking ourselves, does this equal the 4 times negative 2 plus 39? So we're going to have 5 minus, and then this would be a negative 26 when I do 13 times negative 2. And then 4 times negative 2 is 8, negative 8, and then plus the 39. This is going to turn into 5 plus positive 26, so that's 31. Negative 8 plus 39 is 31, and so we know that it checks out. So solving an equation with variables on each side, keep in mind your inverse operations. And again, just pick something from the start to start moving from one side to the next. My suggestion again is to always pick one of those variable terms to start, because then once you do that, you now have what looks like your typical two-step equation. Let's take a look at some story problems. So on this one, we have, again, we're going to write the equation and then solve an equation. This one says the Nathan's Hot Dog Eating Contest is a competition that takes place every year at New York's Coney Island on July 4th. The results of the 2015 Nathan's Hot Dog Eating Contest are shown. So in this table, we can see that we have the winner for the men, and we also have a winner for the women and how many hot dogs that they ate in 10 minutes. So suppose the men's and women's winners, Matt and Mickey, decide to compete against each other. To make the competition more interesting, Matt will not start until Mickey has eaten 20 hot dogs. Assume that Matt and Mickey eat at a constant rate throughout the competition. Based on the number of hot dogs eaten in 10 minutes by Matt and Mickey, how many minutes after Matt starts eating will they have eaten the same number of hot dogs? We're going to write an equation, but before we can do that, we do need to figure out the number of hot dogs they eat per minute. So if they're eating at a constant rate, we're going to figure out how much they eat per minute. So right now, if we take a look at Matt, he has eaten 62 hot dogs in 10 minutes. So we're going to do the number of hot dogs. So let me label this Matt. He does 62 hot dogs, and then we're going to divide that by 10 minutes. And so we know that he's eating 6 2/10 of a hot dog per minute, which is wild. And then for Mickey, we're going to do the same thing. We're going to take 38 and divide it by 10, because again, she's eating 38 hot dogs in 10 minutes. So 38 divided by 10 is going to tell me that she's eating 3 8/10 of a hot dog, per minute. So now that we have that, we can now set up our equation. And again, remembering that Mickey is given a 20 hot dog head start. So when we set up our equation, we are going to set this up so that each situation is equal to each other, right? So because we're trying to figure out when they have eaten the same number of hot dogs. So Matt is eating at a rate of 6 2/10 hot dogs per minute. And so X is going to be our time, right? Minutes. equals the amount that Mickey is doing, so 3 8/10 hot dogs per minute, plus the 20 that she's been given as a head start. Okay? And so that's my equation setup. So we have Matt's information over here on the left-hand side, his rate at which he eats these hot dogs equals the rate at which Mickey's eating her hot dogs plus her head start amount. And now we just solve. So on this one, we're going to start off by subtracting the 3 8/10 x from both sides, which leaves us with 2 4/10 x equal to 20. And then we have one more step, which is to divide both sides by this 2 4/10 so that we can get x by itself. So x is going to equal 8.3 repeating. So if we get x equals 8 and again 3 repeating, hopefully we know that 3 repeating is going to be 1/3. So we can say 8 1/3 minutes is going to go by. And then at that point, they will have eaten the same number of hot dogs. And then that's it. So let's take a look at one more story problem where we're going to be asked to set it up and then solve it. So this one says Marley and Bennett are training to run a marathon. In the first week of training, Marley runs 11 miles and Bennett runs 14 miles. Each week, Marley increases her weekly total by 2 miles and Bennett increases his weekly total by 1.5 miles. We're going to write and solve an equation to find how many weeks after the first week of training that Marley and Bennett will be running the same number of miles. So just like the last situation, we're trying to find when something's equal, right? When are they going to be the same amount? So we first have to look at, again, each person's situation. So for Marley in the first week, she has run 11 miles, and then each week after that, she's increasing it by 2. So we're going to put 2W, so it's the 2 extra miles per week. And we're going to set that equal to Bennett's situation where he's run 14 miles and he's increasing his weekly total by 1.5 per week. Okay, so over on the left-hand side here, we have Marley's situation where she's already run the 11 miles the first week, and then every week after that, so that's that repetitiveness, right? So that's that multiplication here. 2 miles per week equals the amount that Bennett's done. He did 14 miles that first week, plus the additional 1.5 per week that he's bumping it up each week moving forward. And now that we have this set up, we're going to go through and solve. So I'm going to start off by getting rid of the 1.5, just because then I won't end up in the negatives. And so I'm going to subtract the 1.5W from both sides of my equation. If it helps, you could draw that line just to make sure you really are doing the same thing to both sides of the equal sign. We're going to have 11 plus a half W equals 14. And then we're going to go through, we'll subtract 11 from both sides. Now that we have what looks like a two-step equation, we're going to have a half W equals 3. And then we're going to divide both sides by that half. That W is being multiplied by because, again, we don't want that there. And then we're going to find that W is equal to 6. So 6 weeks is how long it's going to take until they are running the same number of miles. So that's going to be it for this video on solving equations that have the variable on each side. Make sure you check out the second part where we're going to explore equations that have grouping symbols as well as giant fraction bars. And then we're going to have a part 3 where we'll look at those situations where we have no solution or an identity. Thanks for watching this one.